Yeah, so good evening all. Uh, Vijay, can you please confirm whether am I audible or not? You can type it in chat box. Okay, thank you, Vijay. So we'll be starting within 2 minutes. Let's wait for other people also to join, and then we'll start. Yeah, so I think we can start now. Yeah. So good evening all. Once again, welcome to our live interaction session of problem solving discussion from PMRF and PTL team. This course is Geotechnical Engineering 2 Foundation Engineering, which is NOC 25 CE 30. Myself, Chitraj Singh Sujawat. I am currently working as a Prime Minister Research Fellow in Department of Earthquake Engineering, IIT Roorkee. This course is currently being tutored by Professor Dilip Kumar Bedia, who is a professor in Department of Civil Engineering, IIT Kharagpur. So those who are joining these sessions for the first time, let me tell you what these sessions are meant for. So these sessions are particularly meant to interact with our learners. We'll be having some of the discussion of the important concept which is required to solve the assignment problems. We'll also be solving some of the sample questions related to the this week question. We'll be solving some of the doubts uh, concerning with the course, not only restricted to the sample questions or the questions of this week, as well as the technical content for that particular week or any other technical query related to this course. Or apart from this, if you have any other non-technical query related to the course, or let's say in general related to the your what are the applications of our course in at industry level, so then also we can uh, utilize these hours to discuss about those questions. So this week's session is particularly meant to understand how the settlement in soil medium take place due to external loading or due to the self weight, or what are the different type of uh, loading stages available whenever a soil is subjected to a certain amount of settlement. So this week course is particularly uh, this week topics are particularly meant to address the question related to that. And so let's start. So here is the first question for you. So among all these four options, you need to analyze the over consolidation ratio, the how the over consolidation ratio is defined. So yeah. So this is mm, yeah. So you can verify your answer once again, and then let's check that. So how do you define the overconsolidation ratio? Yeah, Rajdeep. So you can verify your answer once again. In that case, so yeah, the correct answer is C. So it is basically the ratio of the maximum vertical effective stress, past maximum vertical effective stress, to the current vertical effective stress. So let's say if you are having a certain uh, location, if you have a certain location and you and it is subjected to initially, let's say at time is equals to uh, minus t, or let's say x years ago. So this, due to the in previous construction, the whatever soil element available here underneath the structure, it is subjected to, or it was in the virtue of some initial stress, and let's say after some time this built up area has been removed, and then say this particular construction has been demolished and you want to reconstruct a certain structure again on that particular website, sorry, sorry, so you want to construct the structure again on that particular site. So initially there is some overburden pressure, or there is some initial strength which is already available, which was occurred due to the construction of the structure at some time before. So we'll utilize that particular strength in designing our soil strength, and there it comes the concept of the over consolidation ratio. So over consolidation ratio is nothing but it is the ratio of the past maximum vertical effective stress. So whatever past maximum vertical effective stress available at this particular element to the current vertical effective stress. So this is how you define the over consolidation ratio. So it is basically the ratio of the past maximum vertical effective stress to the current vertical effective stress. So answer is C. Any doubt in this? So it's intuitive by the definition itself. So we can analyze this. So let's move to our next question then. Then you need to select the correct statement about the pre-consolidation pressure represent in the context of soil mechanics. So initially it was over consolidation, now is the pre-consolidation pressure. Yeah, so correct answer is B. So the in the previous topic, the previous question, we have analyzed, we have seen how the particular element is subjected to uh, loading at some certain time, and due to that particular loading, this element has undergone a permanent state of stress, which we evaluate using the over consolidation ratio, and that particular permanent stress which remain in that element due to the past construction or due to some past overburden pressure, that particular state of stress we is known as the pre-consolidation stress. So the correct answer of the second question is the maximum effective stress that the soil has experienced in the past. So this is how you can define this. Just one second. So correct answer is the effective stress that the soil has experienced in the past. Coming towards our next question. So in this particular question, you need to evaluate the consolidation settlement of the clay layer. So if you would have gone through the lectures of Professor Dilip Kumar Bedia, so there are particularly three type of settlement which usually happen. One is the elastic settlement, then second is the secondary settlement which happen due to the consolidation settlement. Third is type of the settlement which usually happens is due to the creep. So in this particular question, you have been asked to evaluate the consolidation settlement. The initial condition of the ground is given to you. So the top surface is 8.2 meter thick saturated clay layer is to be instantaneously covered with a 3.4 meter thick layer of fill materials. The gamma bulk is given to you. If the clay has a coefficient of volume compressibility of 5.5 into 10 to the power minus 4 meter square per kilometer, and a saturated unit weight of 19.6 km per meter cube is given to you, you need to evaluate the consolidation settlement of the clay layer due to the placing of the fill material. Hello. Yeah, Vijay, am I audible?
This is breaking, sir.
Okay, let me check. Is it good now?
Your voice is not clear, sir.
Hello. I think I need to speak louder. Is it good now? You can type it in chat box if it's audible. Yeah, just type it in chat box. Uh, okay, my voice is breaking, is it? Let me restart my meeting. I think everything is good from my end. Hello, 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 hello. Hello.
Yeah.
Uh, what about now? Like, is it all right?
Same it is roaring sound, sir. Your voice is roaring.
Okay.
Okay. And now it is clear, sir. Hello?
Is it clear now?
And now it is clear.
Okay, okay. So, anyways, like if my sound is breaking, though I think everything is good from my end, but then also the you can try the question which is there in front of you, and then we can have a discussion on that. So, I know it's a bit
Okay.
difficult, but let's try to follow that. I'll try my level best that audio is clear to you, because I think the same system I'm using everywhere, I don't get complaint. But I think maybe then uh, things are not turning out right now. But okay, so you can try this question meanwhile. So the question is there in front of you. The top surface of 8.2-meter thick saturated clay layer is to be instantaneously covered with a 3.4-meter thick layer of fill materials. The gamma bulk is 22.1 kN per meter cube. If the clay has a coefficient of volume compressibility of 5.51 into 10 to the power minus 4 meter square per kilonewton and a saturated unit weight gamma sat of 19.6 kN per meter cube, the consolidation settlement of the clay layer due to placing of fill materials. So you need to use the particular relation to calculate the settlement which is happening due to the overcoming overburden, so from at the top surface of the layer. So if you would have gone through the 1D consolidation theory, which basically explain the settlement of the soil layer happening due to the surcharge placed above the soil, then you can particularly analyze the consolidation settlement of the clay layer. Okay, then let's check the answer. So answer is 317.3 mm. So let's say if you are having a certain ground there with you, then you are particularly covering this ground with a fill material, and this fill material is having a height of 3.4 meter, and this gamma bulk which is of this fill material given to you is 22.1 kilonewton per meter cube. This particular clay medium has a coefficient of volume compressibility which is given to you as 5.51 into 10 to the power minus 4 meter square per kilonewton, and the gamma saturated weight of this particular ground is 19.6 kilonewton per meter cube. Then we need to evaluate how much is the consolidation settlement happening in this particular ground. So the consolidation settlement uh, can be calculated as mv delta sigma dash vertical into height of soil layer. So the volume compressibility and whatever increase in the effective stress which is happening due to the placing of fill material, and that settlement of the consolidation you need to evaluate like this. So the consolidation settlement can be calculated as 5.51 into 10 to the power minus 4. Delta sigma dash v can be calculated as 22.1 into 3.4, and the height of the soil layer can be evaluated as 8.2. So this is 8.2. So mv is given to you, delta sigma dash v is given to you, and height of the is given to you 3.4. So let's calculate this. Again, you need to evaluate the imaginary settlement of the footing. So this is basically the settlement which is happening just at the verge of placing the load. So you need to evaluate the pressure transmitted by 3 meter by 3 meter side square footing, which has been placed on a core soil with E equals to 5.24 into 10 to the power 4 kilo to a meter square. Your mu value is 0.38, which is 168 kilo to a meter square. Considering the foundation to be a rigid foundation, the IF value which is given to you is 1.12. You need to evaluate what is the immediate settlement of the footing at the center. So there is a particular relation which has been given to you for calculating the immediate settlement of the footing. You need to utilize that, and then you can find out how to calculate the immediate settlement of the footing and what is the value for this particular question. Any answer, guys? So let's check on this. So answer is 9.2. So usually your settlement which is happening to the immediate settlement is given by q into b into 1 minus mu square by e into if. Okay, so your intensity load coming from the footing is given to you as 168 kN per meter square. The width of the footing is given to you as 3 meter. 1 minus mu square. The Poisson ratio is 0.38 square, and then you are having the elastic modulus as 5.24 into 10 to the power 4 kN per meter square into if value, which is given to you as 1.12, and again this is 168 kN per meter square. KN and kN will get cancelled. Okay, so we don't need to use. So the final value of the immediate settlement for this particular case, which will get it as 1 into 6 into 1 minus 0.38 square into 1.12, answer divided by 5.24 into 10 to the power 4. So we are getting something around 9.21 mm. So the correct answer is B. So for calculation of the immediate settlement, you need to utilize this particular relation, and this had been evaluated by assuming that your stresses are distributing equally, and you need to assume the Hooke's law and utilizing that particular Hooke's law, because we basically assume that whatever immediate settlement which is happening, it's happening due to the elastic settlement, and in your elastic range basically your Hooke's law is applicable, and that's why you can utilize this particular relation to calculate how your immediate settlement basically looks like. So SI is given by Q into B into 1 minus mu square divided by E into IF. So that was about your question number 4. Any doubt in this? Okay, if not so, then let's move to our question number 5. So in question number 5, the average void ratio of a 6.5 meter thick layer of a normally consolidated clay is 1.05. It has a coefficient of consolidation of 3 meter square per year, a compressive index of 0.46. If the effective overburden pressure is equivalent to the increase in the vertical pressure caused by the foundation load on the clay layer, the change in the thickness of the clay layer. Yeah, so this is the case of the settlement which is basically happening due to the consolidation. Consolidation basically deals with the dissipation of excess pore water pressure, and due to the dissipation of the excess pore water pressure, your water is basically getting expelled out, and your particular voids which was having water initially is filled by the soil particles, and due to that particular case, your soil is getting settled, and you need to evaluate the change in the thickness of the clay layer. So please calculate what is the settlement which is happening due to the consolidation. we got one answer D. Let's check for other people for some time and then we'll solve this. Let's check with the answer. The answer is D. It's 40 kilometers. So usually 1 second guys. Let's see. So metaverse. So the settlement which is basically happening is uh, sorry again there's some issue with my pen. Yeah. So the settlement which is happening to the consolidation is given by Cc into h 1 plus e naught logarithmic of your increment in effective stress with the initial effective stress with respect to initial effective stress, and then you have to calculate how your consolidation settlement will basically looks like. So Cc is your 3 meters square per year, h your thickness layer is given it as 6.5 meter, your initial ratio coefficient of compressive index CC is 4.05, which is given to you, and you are therefore the okay, so this is the slope, so it's basically 2 times of sigma naught dash, sigma naught dash, since your sigma naught dash is equal to delta sigma dash, which is given in the question, since the effective overburden pressure is equivalent to the increase in the vertical
Sir, what is the 3, sir?
it has a coefficient of consolidation, it's CC1.
Hello.
Sorry, this is compressive index, so that is 0.46. Yeah, sorry, my bad. Hello. Yeah, is it right? Sorry. Hello, am I audible now?
Yeah,
Yeah,
now it's audible.
yeah, sorry, the compressive index is 0.46.
Audio was slightly disturbing, sir.
Yeah, it's happening today. I'm so sorry for that. Hello.
Yeah, now it's better.
Yeah, I think I need to be little bit louder today. There's some
Yeah,
issue with my microphone. Yeah,
now it is better, sir. 100% better.
yeah. So the effective overburden pressure नहीं मेरे पास नहीं. So the effective overburden pressure is equivalent to the increase in the vertical pressure, and it has a coefficient of consolidation of 3 meter square per year, and the compressive index is 0.46. Sorry, the value is 0.46 compressive index, and your H value is 6.5. Initial void ratio is given to you. So I think the answer which you are getting from this is, uh, let me check. Log of 2 answer into 0.46 into 6.5, answer divided by 2.05. Yeah, so the answer is 0.439 meter, which is your basically 439 mm. So answer is the 439 mm. Then let's move to question number 6. Any doubt in this? I think it's straightforward. If you just know the relation, you can basically calculate the settlement which is happening due to the consolidation. And this is again, if we'll go to the derivation, like it's basically happening due to the our assuming the one dimensional consolidation theory, and utilizing that you can basically evaluate like how the settlement formula basically derives. So this is the relation we basically get, and you can directly utilize this relation to calculate how the consolidation settlement will basically look like. Coming to our question number 6. So again you need to calculate the total consolidation settlement in centimeter. So you have been given with a saturated clay stratum, the thickness is given to you, void ratio is given to you, the final void ratio is given to you. So you need to evaluate how much is the total consolidation settlement. So there is some relation between the change in the void ratio and initial void ratio, as well as the uh, change in the height of the soil layer. So you need to utilize that particular relation to calculate the total consolidation settlement. So that's straightforward relation. You just need to utilize that to calculate the change in the total consolidation. think we have answer. Guys, if you have any doubt in between, please feel free to ask. Yeah, so we'll solve this particular question within 2 minutes. We have one answer. So question number 6b. So let's see this. So usually the relation between the change in the height of the clay layer to the initial clay layer and your change in void ratio with respect to the initial void ratio can be evaluated as delta H, and your height of the clay layer is hello. Sorry, there was some issue with my system, so need to restart that. Thank you so much for your patience. So yeah, we were on question number 7. So yeah, you have been given with the stratification detail which have been characterized using the SPT test data. We usually use the Shermerton influence factor method to evaluate the settlement, and before calculation of the settlement we basically use the influence factor calculation of the influence factor. So question number 7 is particularly meant to evaluate the influence factor at a depth of 1.5 meter below the base of the foundation. Yeah, do we have any answers? So you can refer those particular slides from Professor Bedia's lecture notes, so where he has explained the Shermat and Main's influence factor method. I'll also check that for your cross reference. Let me check whether I have access to that. I don't have access to that, but okay, then let me show you. So the maximum influence factor at 1.5 meter is given by the particular formula: zero point 0.5 plus zero point 0.1 Q effective by sigma dash b. So you need to basically evaluate the influence factor at a depth of 1.5 meter below the base of the foundation. So in that particular case, I think Professor Bedi has also solved one particular example similarly. So you can also cross check that for better reference. So first you need to evaluate the Q effective. So Q effective at the base of the foundation is basically given by, so what is your surcharge value? It's effective foundation pressure. So at the foundation level you are having a pressure of 200 kPa, and you have been asked to calculate the effective, so you need to reduce the overburden from for that particular level, so 18.5 into 3. So your Q effective can which we received value as it's 144.5 kPa, and then your sigma dash b is evaluated as at the base of the foundation. So you have been asked at 1.5 meters, so 18.5 into 1.5 plus depth of the foundation, so which is given as 83.25. So your IF value at 1.5 meter is evaluated as zero point 0.5 plus zero point 0.1, and then you need to use the Q effective. Effective is 144.5 upon sigma dash b is 83.25. So in that particular case, the value you are having is 144.5 divided by 83.25, square root of answer to 1 plus zero point 0.5, that is 0.632, which I am getting. Yeah, so correct answer is 0.632. So this is a particular relation you have to use. The only catch here is you need to calculate the value of the pressure at the level of interest correctly. So here you have been asked to calculate the influence factor at 1.5 meter depth. So you need to evaluate the Q effective for that. So Q effective you need to evaluate at the foundation level. So the overall pressure which is transferring from the foundation level, you need to take the effective in case, so you need to reduce the overburden pressure, and then at that particular depth of your interest, how much is the overburden available, so that you can evaluate using this particular relation. So you need to add the depth of your point of interest, which is 1.5 plus 3, and then accordingly you can get uh, your Q effective as well as the sigma dash b, and then you can calculate IF at 1.5 meter, which is 0.68. So that was question number 7. Then let's move to question number 8. So similarly, you need to evaluate the influence factor at a depth of 7 meter below the base of the foundation. So initially it was here at 1.5 meter. Now you need to evaluate at a depth of 7 meter below the base of the foundation. You can cross verify once. Hello. Hello. Is it audible?
No, sir. For last 10 minutes, no audio.
Hello.
Screen is visible, but audio is nil.
Uh,
Can you hear me, sir?
yes, I can hear you. The hello, hello, hello. Is it audible now? Hello.
No, sir. No, sir. Still.
My yes, okay, okay.
Vijay, am I audible to you?
Yes, yes.
No, sir.
Uh,
My end it is okay.
okay. Uh,
Maybe I will also take a log out and I will once again log in.
yeah, yeah. If that's possible, because I think everything is alright. What about now? Is it audible?
Yes, sir. Yes, sir. It's fine now.
Yeah.
Yes, sir.
So
Okay.
we can solve this particular question number 8. Yeah, answer which I'm having is different. I'm getting it as 0.223. If you can check it once from your end, or else we'll solve this and then we'll analyze this, how we are getting this.
What is the maximum limit of influence depth, sir? I think it is a 2B per square footing.
For the square footing,
Is it or
it's a like usually below the footing we are having the influence up to B, right?
for square footing? I think on square footing the coordinates is a point 1 and I maximum at B by 2 and 0 at 2B.
For the square footing, uh,
At a depth of 2B below the footing, I value is 0.
yeah, uh,
Then you have given 2B means 2 into 3, 6 meters.
yeah,
At 6 meter, if it is 0, 7 meters you don't have influence value. That also to be 0.
no, but B value,
B is given 3 meter by 3 meter, no sir?
B value, let me check. A 3
Yeah.
by 3 meter. Yeah, it's given as 3 meter.
Therefore, influence diagram maximum limit in z-axis is 2b.
Yeah, so you are saying this, right?
As per that, I have given 0. Very nearest answer I have given.
Mm.
Maybe I need to check how you got it. 0.223.
Yeah, just check that once. Even I'll check, cross verify that.
Fine, fine, sir. Fine, sir.
Yeah. It's given it as B, the maximum value of the influence. So let's draw that and see. So usually if this is the influence factor diagram, and let's say at the B you are having the maximum influence, so it somewhere will go like this, and then we are having this type of diagram. The maximum it's a 3 meter, and
Sir, maximum at b by 2, sir.
what's Professor Bedia has mentioned.
For square footing influence diagram, coordinates is at the foundation level. That means at a 0b, it's equivalent to zero point 0.1 I
Point 1.
value.
So here it will be B by 2. Are you saying that? So below the base of the foundation it's 1.5 meter, is it?
Yes, sir.
Okay, so let's assume that here it's your base of the foundation,
Yeah.
and here you are saying it will be 1.5 meter.
Yes, sir.
Okay,
That
so
already we have done it. 1.5 meter we have done.
1.5 meter is how much? 0.632.
Mm.
Now they are asking for how much?
Extreme bottom is a 2B, triangular bottom.
Triangular bottom will be
2B, coordinates is 2B from the foundation level.
okay, so it's 0 comma 2b minus 2b, right?
Yes,
So
2B means 2 into 3, 6 meters.
hmm,
At 6 meter, if it is going to be 0, your question is at 7 meter.
so it will be uh, so at the base of the foundation, below the base of the foundation, it's 7 meters. Okay, so they might have assumed then the linear graph, so that's why it is the issue. So
7 meters comes as out of the diagram.
7 meter 1 point, no, they are asking from the base of the foundation, right?
Yes, sir. Base is the reference for
Yeah.
coordinates.
So that will come out of the this particular part.
Hmm.
So 1.5 meters, then this is 4, this will be your 4.5 meter, then 7 meter will be 1 meter below that. Yeah, let me check that, like this question at 7 meter. So is it for sure it's 2 meter?
Yes, sir. You can see the professor lecture material right now.
Yeah,
Do you
I'll
have
check.
access, huh?
Yeah, I have access, I'll just
You can have access. I will tell page number. Page number 11 in week 4.
week 4 lecture number
Page number 11. Page number 9 out of 11. Page number 9.
which lecture number it is?
Week 4, sir. Week
Okay,
4.
okay, I got that.
Yeah.
So setup
Page number.
number 4, b is the width of the square footing, it's b by 2. Okay, so they are saying at the b by 2 they'll be having the maximum,
And also at 2B it is 0.
at 2b it is 0.
Maybe you have set the question for strip footing or what?
No, I have set it for the square footing only, but I think the calculations I would have done
Or 7 meters, maybe some other value instead of 7.
no
Otherwise, as per your answer, we need to reverse the calculation and we need to check it in some other time.
yeah, then
That
let's make it a smaller value, then that will be favorable. Then let's make it at 1.5 3 4.5 meter, we can say. I'll just change the question, and then let's not go with the options. The main thing is
because if the answer is not matching, the remaining answers also affect because a continuous question 7 to 9.
yeah, depth factor c1 of the foundation. No, we'll just change this particular part.
Okay.
So let's say if I'll calculate at 4.0 meter, and then we'll see how much it's happening.
At 4 meter, you are asking.
Yeah. So in this particular case, it have been asked to calculate at 4 meter. So this will be your 2.5 meter, right? This is your b by 2. So this is 1.5 meter. So how much it will be? So it's 6 meter, 6 meter. So that will be 1.5, 4.5, 2.5. So 2 meter. So you need to, so 2 by x, and then you are having,
We know the IMAX, na, sir.
yeah, so 0.632, right?
Below that, 4 will come. 4 meter means it will come below that. We
Hmm.
assume it's X value.
So I think, is it the answer? 2 by 4.5 into 0.632. How much you're getting?
0.5056. Because at 6 meters is 0 in
Hmm.
between interpolation. Otherwise, similar triangles you can take.
Yeah, I have taken the similar triangle. So this is
X
the
by X by 2 is equal
1.5,
to
2.5, and 2 meter. So at 2 meter, we need to evaluate how much it will be. So
I have taken similar triangles, huh?
yeah, I have taken the similar triangle. So
Uh,
2 by, and this is your whole 4.5, and then at 4.5 you are having 0.632, and how much, how you are getting this 0.55? So
1 minute, sir. I will tell. I will tell.
yeah,
X by 2. X by 2 is equal to.
because I am getting it as 0.281,
One second, sir. Maybe small mistake.
280.
X by 2. A small error I made.
Yeah, it's fine, totally fine.
0.28 or what, sir?
Yeah, I am getting 0.28.
Yeah, yeah.
So the answer is 0.281.
Yeah.
So I sorry, I need to revise that particular question. I haven't checked that. So that's why like I was confused with my solution part.
Your correct answer is 0.28 earlier.
Yeah. No,
Uh,
means I haven't checked that 7 meters. So at the time when I've done that calculation, I haven't. I think there was
okay,
some problem with my influence diagram. So
okay,
then
okay.
maybe that was the issue. But yeah, I think yeah, we can revise this question 4 meter and answer is 0.281 meter.
Mm,
Okay.
mm.
Then
Can you show the screen, sir?
oh my bad.
Your videos. Okay.
Then let's move to question number 9. Then you need to calculate the depth factor of the foundation C1. Again, that's a straightforward relation. You can utilize this. So we know depth factor of the foundation is given by 1 minus zero point 0.5 QS by Q effective. So 1 minus zero point 0.5, and then your QS is basically how much is the overburden pressure available at the depth of the foundation. So that is your 18.5 times of 3, and then okay, how much it is, yeah, and then your Q effective is basically you need to reduce the overburden, so that is 200 minus 18.55 into 3, so it's 18.5 into 3, which is 55.5, and your Q effective minus 18.5 into 3, which is 144.5. So your C1 value will be zero point 0.5 into 55.5 divided by 144.5, 1 minus answer. It's basically I'm getting it as 0.807, which is 0.81. So your C1 value is 0.81. So answer is B, question number B. So straightforward part, so I think this was done. Then let's move to our question number, last question of the day. So the top and the bottom of the normally consolidated clay strata. So you are having a normally consolidated clay strata which is measured 8.2 meters, uh, thickness, per okay, so at both end you are having the permeable layers. So this is permeable layer 1, this is permeable layer 2, this is you are having clay strata 8.2 meters. So the initial overburden here it is as 308 kilopascal. The liquid limit is given it as 66.6%, and your void ratio is given it as 0.79. And now there is some increase in pressure which is 115 kPa. Then you need to evaluate the primary consolidation settlement. Yeah, so how much settlement which is happening due to the consolidation, you need to evaluate that. So I think rest of the formula is same. The only thing here is like with the help of the liquid limit you can evaluate how who's the coefficient of the consolidation can be calculated. Yeah, we have an answer. Let's wait for some time and then we can calculate. We'll solve this particular part. So let's solve this. So you can evaluate your coefficient of consolidation is not given to you. So in that particular case, there is one particular relation which is there. It's 0.009. You are having liquid limit minus 10. Okay, liquid limit you need to put it in percentage. So it's 0.009. Liquid limit is how much? Your 66% minus 10. So your coefficient of the consolidation is 0.504. Then you know the settlement due to consolidation can be calculated as Cc into H 1 plus E naught, then logarithmic of delta sigma plus sigma dash, and sigma dash is the initial overburden pressure and delta sigma is the increment in the pressure. So your Cc value is 0.504. The total height of the layer is 8.2 meter. Your initial overburden void ratio is 0.79. Then logarithmic of delta sigma. So how much is the increment in the pressure? It's 115 plus sigma naught dash is, okay, is it given to us overburden?
It's correct, sir.
Yeah,
115 plus 308.
plus 308. No, I was looking whether we have to calculate or it's already there.
No, both are given.
Both are given. Yeah. So this is the calculation. How much you are getting?
Option B, sir, exact answer. 318.1.
Oh, sorry, it's 308. Yeah.
318.13.
Yeah, so the answer which I am getting is 0.318. So 318 mm. So answer is also 3181. Okay. Okay. So that was the last question for today. So yeah, there were some technical glitches for my end. I'm sorry for that. There was one another glitch in this particular question. Again, I'm sorry for that. But yeah, apart from this, if you have any doubt, please let me know. We can discuss that. Else, we can wind up our session for today. We'll meet next Tuesday at 6 p.m.
Sir, can I take the pictures of first four, three questions?
Yeah, sure.
I am late for the class.
Anyway, like I'll share the video,
Uh,
but yeah, you can take this. So
Uploading will take time, na, sir. When it will come?
it usually be available by tonight.
Then I can go through, sir. No problem.
Yeah, else I can show you. This is question number one.
Okay. It is a theory question. No problem, sir. Skip, sir. Next.
This is also theory
Again,
question,
theory. Okay.
and this was the numerical part.
Okay. This is numerical. Sir, these numerical examples looks like more or less the assignment question similar.
Yeah, so the questions are framed in such a manner such that if you solve them, it's
But the
beneficial
problem
for you
is,
to solve the assignments. Yeah.
yes, sir. But the problem is, if we solve these questions,
Mm-hmm.
then we don't find any speciality in the actual assignment questions. At least one or two should be tough questions in assignment, so that we have to struggle. That is my request.
Actually, miss your this assignment submission date is by tomorrow, right?
Yes, sir.
Yeah. So usually we assume that you have tried your assignment question in last week, and
Hmm.
We'll giving you
Okay.
this assignment one day before, so that if you would have gone through that, so it will be
Okay,
beneficial
okay.
for
I
you.
understood, understood. Before that, we should be able to struggle and everything, and if not, by this time, we should be able to
Yeah. So
clear our
you can
doubts. That is the idea.
yeah, that's the idea.
Okay, okay. Fine, sir. Fine.
Yeah. Thank you.
Thank you, sir.
So I think, can we close it, or if we have
Yes, sir.
anything else?
We
Okay,
can
okay, okay. So thank you everyone for joining today, and those who will watch this video at a later stage. You can post your queries in the comment section of that particular YouTube video. You can also find the PDF of this particular uh, material at the link which will be provided to you by NPTEL team. You can refer that, and if nothing else, then we can meet at next Tuesday at 6 p.m. With our new sample questions. Thank you so much.
Thank you, sir.